Um, my name is Raka, and in this video, I am going to uh, talk a little bit about uh, what. So I'm going to make a comparison between two implementations of Twitter crawler that I made. The first one, uh, I made it like 3 years ago. It was implemented using Scala language and Akka programming framework. Um, Akka, that's how you pronounce it. This thing. And 1 month ago, uh, I make another implementation. This time using JavaScript. Uh, this time using JavaScript and a programming framework called RxJS. So in this video, I'm going to highlight maybe the word the difference between these two implementations. Well, of course, it's not an apple to orange comparison because this one, the later one, has more features, right? Obviously, because I learned something from this one. What motivates me to do the rewrite, right? Well, to be honest, um, in the last couple of months or maybe a year now, I've been doing some systems applications that makes heavy use of RxJS. That's a library for functional reactive programming, and I found that this approach, especially when you're dealing with stream, produce quite an elegant code. I mean, uh, well, a quick, maybe a quick introduction to. Mm, do I need to get into that? Let's see. Before I heard about RxJS, I was quite happy with this library in JavaScript called Lodash that allows me to do list or list transformation and stuff like that in a FP-ish. They call it functional programming-ish. I don't know why, but to me it looks functional enough using Lodash. But this requires that the list is already in the memory, right? So how do you deal with the situation where you got your items coming in as a stream, right? So you can say that RxJS is like the equivalent of Lodash, but for stream data type. It's probably if you're familiar with Spark, it's probably more or less like that. I'm not sure. Yeah, probably the advantage of Spark is yeah, you're sitting on top of the this clustering power that Spark has to offer, or Spark Hadoop, Yarn, all those beasts, right? Um, okay, so that was all though. That was the the only reason why I rewrote the crawler. Be, yeah, beside Ivan, I used to think that the implementation in Akka was quite complicated because um, message passing. Uh, so you have when you analyze the code, it was not really clear uh, how those actors are related to each other. I mean, if you're because there's no a static like type binding, right? You can practically send any kind of message to any actor from. So yeah, it's a the in contrast when you're programming with Java, for example, in the typical object oriented, you know, for example, if you have actor one and you have actor two, and actor two has this function B, C, and from actor one has a function, a method called A, and from A you need to interact with actor two by calling actor two.b. You can easily follow the code thanks to the tooling, like the how do you call it, the auto completion, the you can control click in this function, for example, and then the IDE will take you to the implementation in this actor 2 and stuff like that. But and in the Akka, or you don't have that. uh, so yeah, it was after a while, looking back to the code, I was kind of what did I do there? I wasn't very sure about it. So probably it's not a problem inherent in Akka itself. I mean, it's a tooling problem probably. Um, so back Akka. So we know that what RxJS has to offer. So what about Akka? It's also about functional programming. It comes from Scala. And something that they call actor-based programming. I used to read this thing, Active Manifesto. Make it crash. This thing, I guess. Crash. It teach me both functional programming and actor-based programming. It well, it teach me quite a to me at that time a radical change from my background as a Java programmer at the time, because in Java programming we were taught to be defensive with lots of try catch in our code. Um, what else? Yeah, this one. And here, in quite the contrary, you're fail fast. You're encouraged to fail fast, make it crash, which makes sense in a complex system, because um, it's better to fail fast and react in time, instead of accumulating error. Probably in your attempt to be defensive, not to crash, you're little by little you're accumulating error, right? And then at some point, and then you will end up at some point in the future where the error you have no idea how did you get to that point, right? So that was one difference. And functional, yeah, they talk a lot about immutability, which has to do with a lot to do with yeah, as we all know, that dealing with multi-threading in Java, I mean, maybe in any programming language, is yeah, it's quite tough, hard to debug. So they how do we solve this problem or situation? By avoiding it altogether. That's what I understand from the current trends of programming. That's how you come. That's what exactly Node.js is promoting, right? There you can look. So Scala, Akka, and here the first class citizen is called actor. So what is the difference here? Both of them is functional programming, and this one actor-based programming. Here, let's say in the reactive programming, at least in the RxJS, the first class citizen is called observable or observable or subject, which sounds pretty much the same. Subject and actor actually is pretty much the same. Uh, mm, well, I'm not sure now. I'm not sure now what exactly is the difference in terms of programming paradigm. But probably as we see the code later down the road, probably will reveal by itself, right? Bam, bam. So let's start with the Akka thing. The idea was simple, I think. So here I define several types of actors. It's better with this one. This thing. Here I have crawler manager. As a manager, it manages a bunch of crawlers. And okay, so let's start with these two types. So the role of crawler manager is to so you talk with an actor by passing a command, a message to the actor. They call it command or event. Here in at least in Akka, they call it as an event. Is so each actor has its mailbox and which basically well mailbox is basically a queue of command that the actor has received um, and hasn't been executed and a state. So an actor is a stateful. It can be stateful. Um, so you receive an event. How do you? In this case, this crawler manager receive an event. Let's say known by name search Twitter with this keywords. Let's say YOLO, sunshine, namaste, and what else? Duck face. And as a reaction to this event, this crawler uh, will create a crawler. This crawler manager will create a crawler, and each crawler is in charge of crawling one keyword. How do you? Okay, like this. Search Twitter keyword YOLO. And here sunshine. Namaste. And because I assume that the tweet search result is personalized, that means if you're friends with let's say like rich kids, maybe in the tweets, um, probably you'll get a different result. And if you're friends and you're in the cluster of people who are not that rich, probably you'll get another result, right? So the idea, if you want to get a full coverage of every demographic, uh, demographic in the population, you need to create several Twitter account, and you issue the same search word to those accounts, right? So each one of those account here is represented by something that I call Twitter IO. Now you can make the crawler to talk directly to those Twitter IO, but that would be unwieldy quickly, especially if you consider a scenario that you can uh, add new Twitter account as the crawler is going, right? It's working. So I invent like an intermediate actor here called Twitter IO manager. So, so this is the pattern of message passing or communication is more or less like this now. Okay, and this crawler is in charge of crawling. What does crawling mean? The Twitter search API return the search result in pages, right? So you need to follow the link to the next pages until you hit the end, right? So that's one of the aspect of crawling. And of course, if you want to have some more advanced crawling strategies, you can analyze the content of the tweet and probably follow the retweets and replies and stuff like that, right? So the crawler is that makes the crawler stateful, because you need to keep track of your, let's say, the last page that you're requesting, right? So this is the design, the general design of the Akka implementation of my crawler. I hope I remember that correctly. Let's have a look at the code. So yeah, we got through the crawler manager. It accepts, so it has an initial state, this thing, and then you can ask from outside. You can ask it to start, and I don't know what is it doing here. Out headers, blah blah. Initial query. So here you can see that it creates a spawn crawler actors. These ones, and send crawler name. Yeah, you got the crawlers. Then what do I do with the crawlers? Then I iterate through the crawlers. I don't remember what did I do here. Stop, pause, stop event waiting. You tickle your crawler? What's that? You tickle your crawler. So initially, the crawler is not doing anything. You need to tickle it. That's what was I thinking? article with some search. Yeah, you can see I don't even remember what I did, but I guess that this is more or less the idea, right? Uh, yeah, it's confusing. It's confusing now. But let me just try. So an actor can have it starts with an initial state. This one is the state with all the information that make up the state. This is the name of the state, and this is the data associated with the state. And at any point, as a reaction to an event, you can update the state, set state. Uh, how do you update the state? Oh, yeah, this way. So you can transition from one state to another, and on its way, you also uh, specify what would be the state data in your uh, your next state, right? That's more or less how it works. And because of immutability, you don't, uh, which is encouraged or maybe even enforced here. You don't change your state data. You create a copy of state data uh, with a different value for some or all of the properties, right? New values for some or all the properties. Okay, now back to probably it's quite confusing. So what is the benefit of doing this in a complicated way? Well, as I probably have mentioned, we through the message passing and message queue, basically, we avoid uh, like issues related to race conditions when you're dealing with multi-threading, because here an actor basically executes in one single thread. So this one single thread is like uh, it, how do you call it? There's an external entity which is part of the this actor framework, which assign thread for each actor, in turn, right? Like time sharing maybe. So if you if you're familiar with the Java uh, multi-threading framework, the executor service and thread pooling, probably I'm pretty sure that this actor framework is built on top of that library with thread pooling and stuff like that, and it elevates for us. It elevates the abstraction, so you don't think in terms of threads anymore. You just think in terms of what are the actors, what message it has, what state it has, and how and how the actor reacts to a message. That's all. So in theory, it should simplify your code, right? But well, I think at least in my case here, the reality is not exactly as rosy as in the theory. I end up with still a complicated code, hard to follow. Well, probably part of it is my fault, or I don't know. So that's because of that, I decided to switch to RxJS. But before I get to that, allow me to explain a little bit more about that actor framework. I actually have a presentation about that, which I made like 2 years ago. I guess it's here. yeah, this one. So yeah, so this is more or less my depiction of the actor framework. So these green circles here, they are actors in your system, and you have a dispatcher which maintains a thread pool, and from time to time it assigns thread to each actor. So thanks to like it's like breathing life to the actor, right? And thanks to this thread, this actor can execute the message that is filling up in its mailbox, and then each actor can communicate between themselves by passing messages, events, and stuff like that. Okay, so I made like it was kind of my take on that model. I was kind of guessing about the what's going on under the hood using my little knowledge of Java multi-threading, right? So you got the dispatcher here. You got I made this mini framework of actor mini framework. So I got an actor here. As you can see, it has its mailbox. It has a dispatcher associated with it. How do you? Okay, and a dispatcher in this case is a singleton in the entire application. So you don't talk with the actor by by invoking a method. Instead, you talk with the actor by sending a message, right? So here the actor has a function as a method to receive or to capture the message. Uh, so yeah, that's the entry point to the actor. So here in the example, I create two actors and I send them some messages. Tell. And what does the dispatcher do is so what happens when you send a message to an actor? It will add your message, your command to its mailbox, and it will notify dispatcher about it. Uh, so here it tells the dispatcher that, hey, it's me, and please, give me a thread at some point, right? And here in the dispatcher, uh, basically it queues the runnable for future execution. And when the time comes, this action will be executed. But here, of course, I check if one of the key properties of actor is it's serialized. So the actor process the message in its mailbox one by one. So that's why I have this evaluation. So while the actor is still processing a message, it wouldn't it wouldn't take the next message in the mailbox, right? So it will just here I just return. Otherwise, I will set the actor as busy, and then here I have like a factor of 5. That means it will execute 5 commands in sequence from the mailbox, and then I set it back to not unbusy, not busy, and then notify dispatcher again. What do I do here? Notify. Oh, back to the diagram. Notify dispatcher, and then it asks for another another round of executions, right? But of course, because the dispatcher only has like 2 threads in the pool, so actor 1 will have to share it with actor 2, right? Basically. So that's how it works, I think, under the hood. Um, well, now let's fast forward to the RxJS implementation. One of the new feature that I'm not sure if it's also here, but I know for sure that, of course, that here I have a feature to react to uh, change in the search term, search queries. So the idea is, even well, I mean, while your routine is happily, busily uh, querying the tweet with your initial uh, search keyword, it will react immediately once you have uh, a new or a completely different keywords. So I will and then start crawling. And then we'll get back to that, like the usual BC state, right? That's the idea. I well, since the Scala code is already complicated, I cannot like I cannot tell if I have it there. I don't think I have. It wasn't my plan, I guess, but I never got around to implement that because it's already complicated. I was kind of, oh my god, how am I going to add that feature here in this already complicated code, right? So let's just forget about it for now and fast forward to uh, what? Okay, maybe I can do it like I can tell this crawler manager to kill its crawler here and then simply spawn a new crawlers for which the new keywords. Probably it would be that simple actually. Yeah, but why don't I have that here? I'm not sure. I'm not sure why I don't seem to have that here. If it it is indeed that simple. Okay. Okay, how now the question, how do I implement that using RxJS, right? Um, Here's my code of RxJS. So this is the like the main actor. Here, here. Yep, this one. This is the meat of the crawler, and this is like a spatial break to your crawler. So let's say initially the crawler is doing nothing. It waits for stream of events. So that's how I if you think of think of it as an actor. Yeah, you're coming from this Akka talk. Think of it as an actor, and this would be the command, right? Okay. Initially, it's well, there is no initial state here because we don't maintain state in this stream. So it just checked the type of the event. At one point, like at the beginning of the very beginning of the code, I send an init to that stream of event. So thanks to that, uh, we'll get here, and this event will be passed on to this block. And what does this block do is generating what do I do here? Like a stream of like tick every, like let's say every 10 minutes. So I have a configuration file here. Here I can no here I'm telling my crawler to reset the stream every 15 minutes. Then reset while it resets. Okay, so one single event here will generate um, a ticking. Yeah, so every 5 minutes, and thanks to the switch map, so every 5 minutes we'll get to we'll fall into this block. That's the idea. Every 5 minutes we'll get into this block. So if you don't change your search terms, so every 5 minutes the crawler will repeat the search for the same search terms. Now, what if I change the search keywords? Of course, you want to stop this timer or this ticker. And how do I do that? Using this clock stopper. So once an event is detected in this clock stopper stream, this is also an observable. And subject is like a derivation special type of observable. So once once this observable detects an event in this observable, it will stop. It will stop. And so this the this will not be visited anymore. But because the new queries gets into this block through this event here, this value that return through this true value or whatever value, because I don't really carry a value here. I just need to emit the value here. Thanks to this one, this block will be executed again. So like it's like scrap your old timer and create a new timer. That's how I implement this reactive switching feature. It took me quite a while, because um, trying to figure out what transformation that apply to your needs or scenarios. It takes quite a while. That's the difficulty in reactive programming with RxJ, this library. You need to be well versed with all the operator that it has. So it took me some time uh, to experiment actually. Where was that? Observable. There you go. These are the list of operators that you have on your stream. So it's a lazy, it's a lazy, how do you call it? Like lazy execution, because here nothing's happened. Well, up to this point, nothing happened. You just define the your event processing pipeline. But until you call this dot subscribe, at that point, the event will start flowing from the source down the stream, right? Uh, what else? So even with that difficulty of figuring out the correct operator to use, it is still simpler, easier to understand compared to to my previous implementation in Akka. Well, I'm not suggesting that that reactive programming with RxJS is better than reactive programming using actors. Probably, I this is just because of my inexperience with Akka at the time, not knowing the best practices, all that stuff. But yeah, that's just how it is, right? So I came up with a simpler implementation for for the crawler with more features using this RxJS. Well, so what is the conclusion of this talk? What uh, am I saying that I'm going to scrap Akka for for RxJS or its equivalents? Or maybe the question is when to use actor base and when to use stream uh, programming. Stream. Well, both of them. So that's the question which I myself I don't know the answer. Probably it's it's as easy as asking Google. Actor versus reactive. Man, why? Oh, hey, somebody somebody has a job here. Why Akka is being marketed as reactive? Ah, look at this. Here. Somebody has the same question. Wow, they're actually competitors. They don't complement each other. Hmm. Ah, huh. That's the key. Cross the boundary of single machines. Of course. Yeah. So this crawler that I have here only executes in one single machine, of course, because when yeah, while in actor you can spawn your actor in any nodes in your cluster. Uh-huh. Okay. Fault tolerant, reactive. Okay, yeah, you got the answer. So it's now a question of evaluating your specific requirements and other circumstances in your project and make your decision based on this that and this knowledge, right? What else? I think that's all for now. So see you again. Thank you for listening. Bye.